Hi guys, welcome to Learn Electronics Repair, and I have some resistors on my desk.
The small ones you mean?
Yes, the small ones. These resistors are from AliExpress, and I actually got these as a review sample. Now, why would I want to review resistors? Okay, the wire wound resistors, but what you may not get from the camera is the size of these things. Yeah, so these are 2000 watt 8 ohm resistors, and we'll just measure them just so you can see how big these actually are.
You know what? I wouldn't call this resistor. I would call this a heater.
Yeah.
Yeah, because you can put through 2000 watts through these things.
So these resistors, my ruler isn't even long enough. There we go. So 52 centimeters long.
That's a resistor for you. Yep.
That's a resistor, and about 9 centimeters, 10 centimeters wide.
Are they available in surface mount?
I don't know if these are available on surface mount, but you can mount them to a surface. Look, we have brackets on.
They're surface mountable.
They're surface mountable.
Yeah, but you need a big surface.
Correct. And these are your terminals. So why do we want big resistors? Why might we want these? Well, the simple reason is as a load. And you can get these in various values, but 8 ohms is very good for loading stereo amplifiers. And the reason I found I need this, I've actually fixed a few amplifiers recently, or I've not found a fault, give it back to the customer. He says, yeah, it doesn't fail unless you really give it some welly. And in the shop here, in the shopping centre, I cannot give these some welly. I can't run a nightclub in here, okay? So
sadly not.
Sadly not. And then if we did, there would be an argument between whether it's going to be techno or rock anyway. So that's the other reason. So guys, I'll show you these on AliExpress, and then let's talk about how we can use these to test amplifiers. So here we see these resistors. They come in various powers, 2000 watt being the highest wattage, and various values. 4 ohms and 8 ohms are quite useful for amplifier repair and testing. And bear in mind, I can put these two into parallel at 4 ohms and get 4000 watt. So yeah, I should be able to load just about any amplifier really. You can see the price. So the resistors are 27, 28 euros, but with the two of them, there's 51 euros of shipping. So I actually got these two, and the total cost was about 105 euros. So we know now what we might want to use these for. The question is, how can we use these safely? And the main problem we're going to have with these is heat.
Yeah.
So 2000 watts is a lot of heat. For a short period of time, the resistor will handle that quite happily. But for longer periods, this is going to get very hot quite quickly.
Yeah, and we won't be able to handle this anymore. Yep.
Exactly. And you'll notice, by the way, these like ridge-shaped or wave-shaped striations in the windings. That's not to make them look pretty, and it's not so you can get effectively more wire on the form, although it actually does do that. If they were straight, they would be longer. The other reason is these are designed for forced air cooling. So the idea of this is they cool better with those wobbly.
Yeah, and don't just see Julie, because she probably uses this to cut out little stripes of
pasta.
Christmas pasta or something. Yeah.
Exactly. So we need to put forced air cooling. That means fans on these. And even with the forced air cooling, depending on the power of the amplifier, or if there's a fault on the amplifier, these could get too hot. They're really designed to run about 100, 125 degrees maximum. 125 for short periods, 100 degrees continuous is fine with these resistors. So we need to run them safely, and that's where the bulk of this video comes in, because we need to build some sort of protection circuit. Okay, let's just measure the resistance of our huge resistors to see how accurate these actually are. Okay, so ohms range. That's, yeah.
Looks like 8 ohms, yeah.
Looks like 8 ohms to me. It's certainly close enough. Yeah, 8 ohms, I'm happy with that. Obviously, these are not high precision in any way. The resistance will change with temperature. What we really need to be able to do is monitor the temperature at, say, for example, 100 centigrade. If we go above that, some sort of audible warning, a bleeper or something. And then we have the option to turn the power down a bit on the amplifier.
Or maybe switch on a fan.
Or switch on a fan. Although I suspect we probably best just to have fans anyway. But yes, we could do that with fan control. And if the temperature of the resistor gets above 125, we should shut off the amplifier. And the best way to do that is not to disconnect the load, effectively the speaker, when the amplifier is running near full power, but to switch off the main supply to the amplifier. And another consideration regarding safety, not only the temperature, but a power amplifier, big one, can easily put plus or minus 100 volts. So 200 volts peak to peak across the resistor at full power. So we also have to consider the possibility of electric shock.
Yes.
And protect from that.
Safety. Yeah. And we are absolutely aware that we can't run this in the shop. This is we'll get into 2,000 watts per resistor. So in worst case, we have a 4,000 watt heater here. And we live in Gran Canaria. It's already warm here.
Yeah. So we need to find a way how to also solve that problem. And we'll tell you about that at the end of the video. So that's what we need to do to use these. And this is where Detlef comes in, because this sort of automation and monitoring, I believe, is your expertise.
Oh, bleep. Should we use an Arduino?
Yes, Arduino. And what we're going to do is, we're not going to design a project with a PCB. We're going to do this a different way. So we're going to buy off-the-shelf modules, something you could put together on breadboard or just wire together, or a bit of Vero board, and make a comprehensive temperature monitoring and safety system for our resistors.
So no complicated PCB design included. This is all off-the-shelf modules. Yeah, and let's show the people.
Let's do it.
Yeah. So I'd say it's the brain of the operation. I'd simply use a Nano, because cheap.
Yeah.
Everywhere, everybody has a Nano lying around. We probably have some in the shop here. So this would be fine, because, this thing doesn't need to do much.
Okay.
It just needs to measure a temperature, check if it's fine with that. If it's not fine, maybe switch on the fan. If it's not fine with that, cut the whole power off the thing.
Or the bleeping.
Or the bleeping as a warning when the fan goes on or something.
Yeah. And then shut off if it's still getting too hot. Okay.
Yeah. So this would be the brain of the operations.
Okay.
So what would you say? We need a bleeper, right?
Well, we need a sensor first. So we need input. So how are we going to monitor the temperature?
Okay. So this would be my choice for the measurement thingamajig, DS18B20.
Okay. What is this, Detlef?
This is a simple one-wire sensor that simply measures temperature,
Okay.
Very, very easy to use, and there's a library for that. So the hard work is already done.
Can I just say, I can see 3 wires on that, and you say it's a 1 wire?
Power and 1 wire.
Okay, that's 2.
Yeah.
Power, ground, and 1 wire.
Yeah, so interestingly, the thing comes with a weird construction is from Dallas. DS is Dallas, the first letter, and they had a thing where they constructed a bus which is parasitic. So in the sensor itself lives a little capacitor.
Yeah.
And if you ask it, send me data, it uses the power bus to simply send data back and forth. So
now, in fact, it uses 2 wires, power and ground, and the data comes, but the 1 wire data comes back down the power. Yeah. So there's only 2 wires. I mean, another great thing with this, it's waterproof as well, 5 meters long.
5 meters. So
yeah. So we need 2 of these.
Yeah, we probably need 2.
1 for each resistor.
Yeah, I normally go for 5 because playing around with these things kills the stuff.
Yeah, I mean, it may be a good idea to put 1 sensor at the end of the resistor and 1 near the middle or something.
Or we simply drop them. There are little holes in the resistor. Maybe
1 on the inside, 1 on the outside.
But this is something we figure out when we're building the thing.
Okay, so we get 5 of those. And
we have enough.
We have enough. Okay.
We have enough.
So that's how we sense the temperature.
Yeah, and this goes to, it tells us down here, 125 degrees. So this is in the range you're saying.
That's the shutdown point.
You want to use. Yeah. And it's really easy to use. I use them a ton. Yeah.
Okay.
So, that's very easy to use. Yeah.
So that's the sensor. So when we reach the first warning temperature, we want to bleep. We want to hear something.
Okay, let's go for a bleeper. So again, a pre-made module here. I'm going for a little active buzzer here. This won't be ear deafening.
No.
But it would be enough to signal, okay, I'm doing something here. Or you can do a
that sort of thing. Yeah, something noticeable.
Yeah, like your microwave is done now or something.
Yeah,
or something
okay.
like that,
That gives a bleeping. Can we actually see what the temperature is?
I would suggest to do that because want to know what the temperature on the things actually is running.
Okay.
Let's see look for a little display.
Ah, and this one.
Yeah, and these are 3 of them. So for 650, and this is a 1.3 inch display. So it's not a tiny one. It's a little one, but it's not teeny tiny. So this is fine for doing something like that.
So we could use effectively this with measure 2 of them. So we have 2 displays, 1 for each resistor.
We would use 1 display and have 2 temperature.
2 readings on the 1 display.
Sensor 1, sensor 2, something.
Yeah, great.
Yeah.
Okay.
Yeah. This will run over I2C from the Arduino, so Arduino will be fine with that. So there's a little display.
Okay. And then we need some way to switch off the power to the amplifier if it reaches the maximum limit of 125.
Well, yeah, we need some big contactor there.
A contactor.
Contactor.
Which is this thing. So this is a high power 220 volt contactor. This is like a big relay, basically.
This is a big relay. It's normally used to control a motor.
Okay.
So you see, when you look over here, L1, L2, L3. So this is a 3-phase motor controller. And this is able to really switch this off. So when there are 12 amps going through this, this is able to break the connection here. So if you're using a little relay, it probably won't work, or maybe it works 10 times and then 12 times.
It will fail, yeah.
Kaboom.
I also noticed on here, the last contact connection is NO, normally open. Now, Dell FM itself were talking about this. What happens if the Arduino crashes? Or something like that. Okay, so we use the normally open contact. So the Arduino needs to switch this on. If the Arduino isn't running, the power's gone off, this would be normally open.
Yeah, so
fail-safe.
Yeah. So as a fail-safe, we go for normally open. So this must be actively switched on.
But to switch this on, we need 220 volts on the coil of this.
Damn it, Arduino can't handle 220? Really? Okay.
Nope. So how do we get around that?
Let's go for a little relay.
Oh, okay. So here is the solution to that problem.
Yeah, we're switching a relay with a relay.
Okay.
Yeah, these are pre-made little modules with little relays like these. Yeah, I know, they're saying 10 amps 220. No.
You wouldn't switch the main power to the amplifier. So we're going to use this relay to switch the 220 volt coil on the contactor, the breaker.
Yeah.
Okay. And actually that module has 4 relays on here. Well, can we use the other ones to switch on the fans?
Of course. Fans won't draw as much current, so you can use 2 channels to switch the relays, maybe for 2 of these things.
Okay.
And then you have 2 channels left to switch on fans.
Okay, great.
So I would go for a 4-channel module. You can get 8 channels here, then they don't cost an arm and a leg. But for just being on 4 will be fine.
Should be fine.
Yeah.
Should be fine.
We're probably getting 2 or 3 of these modules. So if we need to expand, just go for this. The control is pretty simple because VCC and GND, so 5 volt. And then you simply have 4 channels. So this is 4 digital pins on the Arduino, and just simply switch it on.
Switches the relays, yeah.
And
so easy.
They also have these little isolated built in. So Bob's your uncle there. There's a little transistor that probably switches the relay, the coil of the relay.
And these are 5 volt relays.
5 volt over there. It says 5.
5 volt. Okay. So what else do we need? Oh, we need power.
We need the 5 volts somewhere.
Yeah, 5 volts. So how are we going to get the 5 volts?
So you could go for something like a power brick, like just a USB power supply. I would suggest, since we have the relays, they come on a little C mount. I would suggest something like this.
Oh yes, a DIN rail mounting power supply.
Yeah, so this is mounted on a DIN rail, and this is a meanwhile. So it's not the cheapest one. I know this is way more expensive than your ordinary power brick, but this is meanwhile.
This is 15 watt 5 volts.
Yeah.
And to be quite honest, these type of power supplies are designed to be running continuously. They probably have much greater reliability than using something like a USB power brick. So yeah, for €10, I mean.
Yeah.
I would agree with that. Yeah. Okay, so that's power.
So what happens when everything fails? You need a fail-safe thing.
Emergency stop.
Emergency stop!
Yes, we need it. True. Okay, so again, emergency stop button. We can just buy this with a little case. Yeah, that's ideal for that. So if something badly goes wrong with the amplifier, just hit the stop button.
And these are self-locking. You see a little turning thingamajig here. That means when you hit it, it won't come back on. You need to turn the
turn it to come back on. Okay, so we have an emergency stop.
The mounts is in the power part of the contactor, so even if the CPU does something weird, this will cut the contactors off.
Yeah. So great. So we have an emergency stop. And there's one other thing that would be nice to have with this. So when we're driving these big resistors, obviously we're not being blasted away by techno. But techno is better for testing amplifiers. But it would be nice to be able to hear the audio.
Okay.
So that we can actually think, oh, it's distorting. Now I'll just show you very simply a little circuit diagram how we would do that. What we need for this is a little stereo amplifier module.
Let's see if we find some. So there's a little. Are you fine with 2 times 5 watt?
2 times 5 watts is absolutely fine.
Yeah, so that would be one. So this is a little easy board.
Okay.
There's a 5 volt in, so it's the same voltage for the power supply, like.
So we could build this into the same enclosure with everything else.
Yeah. This is where you normally get in, but there's look at this there input.
Ground light, ground right, left.
Anyway, you can go for a D amplification or an AB amplification. Oh, interesting.
I would say that switches the amplifier between class D and class AB.
Yeah, it does.
Interesting.
Yeah, and then you got 2 outputs.
Speakers.
Left and right. Yeah.
Audio right and left, okay.
Doc Bob's your uncle.
Okay.
You know what? I can't build this for $329.
With free shipping.
With free shipping. Crazy,
exactly. So guys, that's what we're going to do with that. Now, we've talked ourselves about mounting these. The best way to mount them would be to fit these onto large metal plates, okay, and then bolt the large metal plate to the wall, an outside wall, something like that. But because our workshop here has no opening windows or anything, we have the aircon, but that's it. If these are running even with, say, a 600 watt per channel amplifier, that's 1,200 watts. And if we want to run this amplifier for 30 minutes to 60 minutes to soak test it, that's going to kick out some heat.
Yeah, you need swim trunks. Yeah.
Exactly.
You're sitting around here naked.
And it's warm enough in here anyway right now. Even in the last week of November.
4 weeks to Christmas right
4
now.
weeks to Christmas thereabouts. It's 29 degrees in here. Okay. So it does get warm, and it's winter for most of you, okay? So the best plan I came up with was to stick these on the roof. Directly above me is the roof of the shopping centre. And there's a lot of equipment up there, so I don't see any problem, but I do need to ask permission. Any problem putting these up on the roof, okay? And the control unit would be down in the workshop. Obviously, if we put these on the roof, 2 things. We need some sort of cage around them to stop people touching them. And then some sort of cover over the top. Some sort of metal cover or plastic cover to stop them getting wet if it rains. But to be honest with you, it rains here so infrequently.
Rain? What is this?
Yeah, I know. It's water falling out the sky. I've heard about it.
This sounds weird.
I've read about it, so that, I think, is the best way to put these outdoors on the roof here, because that's the situation. And also that means we can make some really nice video up there, get our cameras up there, and you can see us fitting these. We need 4mm wiring to come down from the resistors, okay? But if it's not easy to get that, just use like 2 lots of 2mm in parallel. And then I was thinking, what sort of connectors? Well, speak on connectors, because that's what's on the back of the amplifier.
So you can speak on,
Yeah. So, guys, that's it, I think.
Yeah, this is a nice planning thing, you know? This sounds like a reasonable project.
Yeah, I think so.
And software won't be that complicated, because we're just measuring temperatures, and you have thresholds and
switching things.
Yeah, from there on you go, okay, what you do when threshold is
you do this or you do that.
Yeah,
so that shouldn't be too difficult at all. And I'll put links in the video description to the various modules if you guys are interested. I think it's really interesting to build stuff this way. It's something we've not done on the channel before.
True, yeah. We normally go for PCBs here, but this time we're going for without them. Yeah, just breadboard.
Just to do it the other way.
Yeah. You probably realize this is not a project that you probably want to build, because this is very specialized, but this is something that we can show you how to approach this kind of things.
Yeah.
This was the idea behind this video. Yeah.
Although, having said that, if any of you guys are repairing power amplifiers and car audio and this sort of stuff, really, this is the only way to do it. And I'm sure At least you over there and Dutch Linux over here.
Ah.
We'll agree with that.
Dutch, of course.
Of course. Okay, guys, so that's it. Thanks for watching, and we look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now.